Hello everyone, welcome to Sangam Tutorials. Gubbi online classes for NCERT and Cbse for mathematics and science. So in the previous session of mathematics we had discussed concepts on similar triangles. So we had been proving theorems, that is based on similarity criterions of AA similarity criterion, SA similarity criterion and SSS similarity criterion. So before proving the theorems we went with some lemmas which were required for proving the theorem, that is the previous knowledge required for proving the theorems, and then we went with the AA similarity criterion as the first theorem, which is if two triangles are equiangular then they are similar. If two triangles are equiangular then their corresponding sides are proportional. So both the statements carry the same proof, but at the end we will go with just one extra step, that's all. Next we go with another similarity criterion, that is SAS similarity criterion. So in this criterion, if one angle of one triangle is equal to one angle of the other triangle and the sides containing these angles are proportional, then we say that both the triangles are similar. So this is called SAS similarity criterion. And regarding SSS similarity criterion, where you do not have the proof for this in your textbook, so we have proved the entire theorem. So I hope you have enjoyed all the three theorems. So according to SAS similarity criterion, if three sides of one triangle are proportional to the three sides of the other triangle, then both the triangles are similar to each other. So this was SSS similarity criterion. So with these things, in today's session we will be going with riders, purely riders on AA similarity criterion, only riders. So numericals, after this we will come into the numericals on AA similarity criterion. So before entering into this session, better you recap the entire theorem, that is AA similarity criterion theorem once, and enter into this session, and if you remember it, it's well and good, right? So we will go with some 4 to 5 riders today, which are very important. You have to practice these riders. Once you get a grip on this riders, it will be very easy to solve some more riders on the remaining two theorems. So we will go with the first problem today. So here we have triangle BAC and triangle BDC. So here we have two triangles. One is triangle BAC and triangle BDC. So here in triangle BAC we have one angle equal to 90 degrees, and in another triangle BDC we have one angle equal to 90 degrees. So in a triangle, if one angle is equal to 90 degrees, then it is called a right angled triangle. So we have two right angled triangles with a common base. So that's the common base or a common hypotenuse, because in triangle ABC, if you take the side opposite to the right angle is called as the hypotenuse. So in triangle BDC, angle D is 90, therefore the side opposite to the right angle is the hypotenuse. So both the triangles are sharing the same hypotenuse, right? So triangle BAC and triangle BDC are two right angle triangles with common hypotenuse BC. So BC is the hypotenuse here, which is the longest side in the triangle. Okay. The sides AC and BD intersect at P. So in triangle ABC, the side AC, and in triangle BDC, the side BD, they intersect at point P. Now, using this data, you have to prove that AP into PC, that is AP into PC, is equal to DP into PB. You have to prove this, right? So before getting into that, we get the corresponding sides ratio. We have to find out the corresponding sides ratio, and then by cross multiplication we have to reach that particular step. So here most of the students gets confused because it is given triangle BAC and triangle BDC. So they try to take triangle BAC and triangle BDC and prove that as similar triangles, and then try to prove the given thing. So it's not possible, because here AP into PC is given. So AP, PC sides are involved, and DP and PB sides are involved. DP and PB sides are involved. So this side and this side this side and this side. So the four sides are involved in these two triangles. Not triangle ABC or not triangle BDC we get it, but we get it in these two triangles, that is triangle APB and triangle DPC. So therefore selection of triangles while solving Ryderson criteria, that is similarity criterions, they play a very important role. Once you get all these things, once you are aware of all these things what I speak to you, it will be easy for you for solving Ryders, right? So select those two triangles where all the four sides which are being discussed here, that is you have to prove that AP into PC is equal to DP into PB. So select the two triangles in such a way that all the four sides are included in that, either in one of the triangles, either this or that. So AP into PC, AP, PC, AP is involved in this triangle, PC is involved in this triangle, DP into PB, DP is involved in this triangle and PB is involved in this triangle. Therefore you can select these two triangles. That's the way of selecting two triangles, right? So we'll prove that. Okay. Now the description of the diagram is called data. So let us write the data here. So triangle ABC, BAC and triangle BDC are right angled triangles, okay, with the hypotenuse BC, common hypotenuse BC. So hypotenuse is BC, okay. So AC and BD intersect at P. Okay, so this is enough. So we'll go with the next step, that is to prove that. So we'll see what is to be proved. So it is there. So AP into PC is equal to DP into PB. So what this means, we will prove that. Okay, we'll go with the proof. So no extra construction is required. This data is enough to prove this. So we have to select the triangles. That selection is very important. So in triangle APB and triangle DPC. So in triangle APB and triangle DPC, right? So in triangle APB and triangle DPC. Now angle BAP is equal to angle CDP, that is 90 degrees and 90 degrees. So in the right angle triangle ABC, angle BAC is 90. In triangle ABP also angle BAP is 90. So that's how we select it. So in triangle ABP, angle BAP is equal to 90 degrees, and in triangle PDC, angle CDP is equal to 90 degrees. So angle BAP is equal to angle, that is CDP. So both are equal to 90 degrees. So that 90 degrees, it's according to the data, because whenever if two angles are equal and if you write the angle value, you have to write from where you got it, that is you got it from construction or you got it from the data. So I have written angle and also I have written the source of that angle, that is we have got it from data, right? So here AC is one of the side and BD is one of the side. So therefore AC as it is a straight line and BD as it is a straight line, these two straight lines meet at a point P. So you have learnt in your 8th standard class that if two straight lines intersect at a point, a particular point, a unique point, then the vertically opposite angles are always equal. So here angle APB, that is this angle, is equal to angle DPC, that is this angle, that is both are vertically opposite angles, right? So we write the angles now. Angle APB is equal to angle DPC. So this is vertically opposite angles. So most of the students like it VOA, don't write all those things. Please write the spelling. Vertically opposite angles. Now in the first triangle APB, there are two angles, and in the second triangle, that is triangle DPC, there are two angles which are equal. So these two triangles have two angles which are equal, that is corresponding angles are equal, that is two pairs of corresponding angles are equal. So in any two triangles, if two pairs of corresponding angles are equal, then we call those triangles are as equiangular triangles. So therefore triangle APB and triangle DPC are equiangular. They are equiangular. So this is the very important statement you have to write. So you are telling us that both the triangles are equiangular based on a criteria here. You are using a criteria here. So what is that criteria? So according to that criteria, triangle APB is similar to triangle DPC. So this is AA criterion. So here when you mention two triangles to be similar, compulsory you have to write by on what basis, that is on which basis both the triangles have become similar. That is, you have to write the criterion which is being used to prove both the triangles are similar. So now these two triangles have become now similar to each other. So now we get the rights, because according to AA criterion, if two triangles are equiangular, then their corresponding sides are proportional. So now we have to write the proportionality of the sides. So practice one thing I tell you here. Write all the three ratios of the corresponding sides in both the triangles, where one will be useless. One particular ratio will be of no use. Leave it. Take the required ratio and prove what it is asked. So that is how you have to go with this. So just to avoid confusion, I do it. So in this triangle, this is right angle, this is vertically opposite, and this is the third angle. Mark like this. So in this triangle, this is 90 degrees, this is vertically opposite, and this is the third angle. Now it's very easy to write the corresponding sides of similar triangles. Now in this triangle, that is in triangle APB, this is 90 degrees. The side opposite to 90 degrees is BP, and in this triangle for 90 degrees, this is the corresponding angle. So side opposite to this right angle is PC. So therefore, for in triangle APB, for the side BP in triangle DPC, right, PC becomes the corresponding side. For BP, it is PC. Why? Because this is right angle, this is right angle. The opposite side to the right angles are BP and PC. So we'll write the ratio here. So therefore, BP by PC is equal to, they are the opposites to right angles. Now we will go with vertically opposite. So in triangle ABP, for this angle, opposite to this angle is the side AB. So for this angle, this side is opposite. For this angle, this is the corresponding angle in this triangle. So therefore, opposite to this angle is DC. So therefore, for AB, DC is the corresponding side. This is the technique. So AB by DC. AB by DC is equal to, now remaining second angle, that is this angle, third angle is this. So in triangle APB, opposite to the third angle is AP. In triangle PDC, opposite to the third angle is PD. So therefore AP by PD, that is AP and PD are the corresponding sides. So is equal to AP by PD. So reason, corresponding sides are proportional. Corresponding sides are proportional. Now look at the thing what is to be proved. So you have to prove that AP into PC is equal to DP into PB. So look, where is AP? AP is here, PC is here, DP it is here, PB it is here. So ignore this ratio and consider these two ratios. Very simple. So take those ratios. Therefore BP by PC is equal to AP by PD. Go with cross multiplication. So what is AP into PC? That is AP into PC is equal to BP into PD or DP into PB into BP. Right. So this is what it was required to be proved. So hence it is proved. So this is a very important 2-mark rider which is based on AA similarity criterion. Okay, we'll go with the next problem. In the figure, angle QPR is equal to angle UTS, which is equal to 90 degrees. That's the given data. And PR parallel to TS. PR is parallel to TS. So therefore, prove that triangle PQR is similar to triangle TUS. We have to prove this. We have to prove that triangle PQR is similar to triangle TUS. So this is the given diagram. They are given the diagram here. Okay. So right. Now we'll get into the problem here. So it's very simple and very interesting, right? So in the figure, angle QPR, that is equal to angle UTS. So both are equal to 90 degrees. So and PR parallel to TS. So PR is parallel to TS. So this is the given data. So using that you have to prove that triangle PQR, that is this triangle, is similar to triangle TUS, that is this triangle. You have to prove that both the triangles are similar to each other, right? So we'll go with the data. Very simple, very interesting problem. So we'll write the given data here. So angle QPR is equal to angle UTS, which is equal to 90 degrees, and along with that PR is parallel to TS. So we have to prove that. To prove that triangle PQR is similar to triangle TUS. So this is what we have to prove. So we'll go with the proof. Right now. So we will select these two triangles. We'll select these two triangles now. Right. So in triangle PQR and triangle TUS. In both the triangles, triangle PQR and triangle TUS, right? One angle is given, that is angle QPR is equal to angle UTS, that is one pair of corresponding angles he has given, and those angles are equal to 90 degrees. So equal angles are called as corresponding angles. So therefore I can consider these two as the corresponding angles. So therefore angle QPR is equal to angle UTS, that is UTS. This is 90 degrees. How you got this? I got it from the data, right? So it is 90 degrees and it is according to data. Now, in order to prove these two triangles to be similar, I have to prove that they should be equiangular. If I want to prove that they are equiangular, minimum I have to show that their two pairs of corresponding angles are equal. I have to show that. So in the data it is given only one pair of angles, then we have to search for another pair of corresponding angles which are equal by looking at the other data, that is PR parallel to TS. Okay, let us see this. PR is parallel to TS. Okay, I will, for my convenience, I am going to extend these two lines. I am going to extend these two lines like this because they are parallel to each other. Now, these are the two parallel lines and this becomes the transversal, that is QUQ, that is QU becomes the transversal. So if two parallel lines are intersected by a transversal, then we say that the alternate angles are equal. So let us identify the alternate angles. So here angle PRS, that is this angle, is equal to angle RST, that is this angle. So these two angles are going to become that is alternate angles. So according to the previous theorems what we have done, we can come to a conclusion that if two parallel lines are intersected by a transversal, then the alternate angles are always equal. So therefore angle PRS is equal to angle, that is UST, this angle UST. So they are alternate angles. So therefore in both the triangles, triangle PQR and triangle TUS, two pairs of corresponding angles have become equal. So if two pairs of corresponding angles are equal, then these two triangles are equiangular. According to A criterion, if two triangles are equiangular, then they are similar according to AA similarity criterion. So therefore triangle PQR and triangle TUS are equiangular. They are equiangular. So therefore triangle PQR is similar to triangle TUS according to AA criterion. Right. So this is, hence it is proved. I hope you enjoyed this. See, very crucial, very important. If you want to alter the diagram, you can alter this. No restriction. If I alter something, it may happen something. Don't worry about it. It's your diagram. You can alter in any way you want to analyze the given data. You can do it. No doubt in that. Alright. So this is for 2 marks. Very important. Right. Let us go with the next problem. Right. In the figure, angle ABC is equal to 90 degrees. ABC is equal to 90 degrees and angle AMP is equal to 90 degrees. AMP is equal to 90 degrees. Right. So prove that. First one, triangle ABC is similar to triangle AMP. ABC is similar to triangle AMP, and second one, CA by PA is equal to BC by EMP. So I have to prove two things here. So once you prove similar, second thing just carries along with that. So this is the required diagram. So let's go with the diagram here. Right. So this is the right angle triangle. So this is A, B, P, M, C. So this is 90 and this is 90. Right. So this is the given data along with the diagram. They have given the diagram. You have to just follow that. Okay. So in the figure, angle ABC is equal to 90 degrees. ABC is equal to 90. Okay. And angle AMP is 90. AMP is 90 degrees. So prove that triangle ABC is similar to triangle AMP. that is this triangle is similar to this triangle. So both are right angle triangles here. And also prove that CA by PA, CA by PA, CA by PA is equal to BC by MP, that is BC by MP. Okay, we can do it. So once we prove that both the triangles are similar, then we can look into the that is corresponding sides. Okay, let us go into the data. Description of the diagram is data, right? So angle ABC is equal to angle AMP is equal to 90 degrees. So both the angles are equal to 90 degrees. So to prove that, so first one, triangle ABC is similar to triangle AMP, and second one is CA by PA is equal to BC by MP. Right, this is hint. So we'll go with the proof. Right, very important. So no other go, we have to take both the triangles, that is we have to select both the triangles. So select in a very systematic order. So in triangle ABC and triangle AMP, so in both the triangles, right. So first we have named the triangle ABC, therefore we have to write the angles of triangle ABC first and then angles with respect to triangle AMP. Now in triangle ABC, angle ABC, that is angle ABC is equal to angle AMP. So angle ABC is equal to angle AMP. So both are equal to 90 degrees. How you got it? So we got it from the data, right? So in order to prove these two triangles to be similar, one pair of angles we have made equal, we need another pair of minimum is another one pair of corresponding angles to be equal. So we have to select it. So we have to look very keenly here. So in triangle ABC, angle CAB, and that is this angle, and in triangle AMP, angle MAP. So this angle is common for both the triangles, that is triangle AMP and triangle ABC. So this angle is common, that is this angle is present in both the triangles. So an angle present in both the triangles can be called as common angle. So here angle CAB is equal to angle MAP. Angle CAB is equal to angle MAP. So angle CAB is equal to angle MAP. So according to that is common angle. So therefore in triangle ABC and triangle AMP, two pairs of corresponding angles are equal. So therefore both the triangles have become similar. So triangle ABC and triangle AMP are similar, or equiangular, right? So once they become equiangular, according to theorem 1, that is A criterion, they become similar. So therefore triangle ABC is similar to triangle AMP. So this is according to AA criterion. According to AA criterion, both the triangles are become similar, right? So first question we have answered. Second, we have CA by PA is equal to BC by MP. So now we will do one thing. We will write the corresponding sides of all the three corresponding pairs. That is ratios of both the similar triangles, corresponding sides ratio of both the triangles. We will write all the three. Then we will select the required two. Right. Before getting into that, we have to select the third angle here. So in triangle ABC, this is 90. In triangle AMP, this is 90. One is ready. This angle is common for both the triangles. So in triangle ABC, leftover angle is this one. That is angle C. And in triangle AMP, leftover angle is the third angle, that is this one. So those angles which are equal, we should mark them by same designs. So these two angles are equal, same design. This angle is common, okay? So these two angles are equal, therefore you have to give the same design so that you are not confused while writing the corresponding sides. Right, let us go with this. So now, in triangle ABC, right, 90 degrees is here. The side opposite to 90 degrees in triangle ABC is AC. So 90 opposite is AC. In triangle AMP, 90 opposite is AP. So that is AC by AP. So therefore AC by AP is equal to, we will go with the second one. We will concentrate on the common angle. So in triangle ABC, this is the third, that is common angle. Common angle opposite side in triangle ABC is BC because this is the opposite. So in triangle MAP, for this angle the opposite side is MP. So this is BC by MP. So that becomes BC by MP is equal to, now we will look at the third angle. So in triangle ABC, this is the third angle, opposite to that is AB. In triangle AMP, this is the third angle and opposite to that is AM. So third angle opposite here is AB and third angle opposite here is AM, that is AB by AM. AB by AM. Right, so now we have to prove AC by PA, that is CA by PA. So here AC by AP, both are one and the same. CA means AC means same, PA, AP both are same. BC by MP, so this is not required. So therefore AC can be written as CA by AP can be written as PA is equal to BC by MP. So here you have to write the reason. Corresponding sides are proportional. Corresponding sides are proportional. So hence it is true. So this is also a very important rider. Most of the students, what they feel difficulty is identifying the corresponding sides which are opposite to the corresponding angles. So once you start practicing, once you look deep into the diagram, you can get that skill of identifying, right? Okay, we'll go with the next problem. Let us go with the fourth problem, very important. It was once asked in the final examination of SSLC state syllabus. So in the figure, angle ABD is equal to angle BDC. Angle ABD is equal to angle BDC and CD is equal to 4AB. CD is equal to 4AB. Show that BD is equal to 5BE. BD is equal to 5BE. Okay, let us go with the diagram. Right, so this is the given diagram here. So let us go with the data. Right, and continue. So in the figure, angle ABD is equal to angle BDC. Angle ABD, that is this angle. Angle ABD, angle ABE are one and the same. Just the length of the side increases, but the vertex remains the same, right? Is equal to angle BDC, that is angle BDC. So angle BDC is same as angle EDC. Just the length of the side decreases, but the vertex remains same. So these two angles are equal. This angle and this angle are equal, right? And CD is 4AB. The length of CD is 4 times AB. That is, if the length of AB is, for example, if it is 2 centimeters, then the length of CD will be 4 into 2, that is 8 centimeters, something like that. So the length of CD is 4 times AB. If this is 1 centimeter, then it is 4 centimeter. If that is a thing, show that BD is 5 times BE. BD is 5 times BE. That is, the length of BD is 5 times BE. That is, if BE is some 2 centimeters, then BD is 5 into 2, that is 10 centimeters, something like that, right? So let us go with the data. It's very simple. So angle ABD is equal to angle BDC. This is according to data, and very important, CD is equal to 4AB. So to show that BD is equal to 5BE. BD is equal to 5BE, right? So it's very important problem. It was asked in one of the examinations. So you have to practice this. Right. No construction is required, just we'll go with the proof. Now, select these two triangles. Let us select triangle ABE and triangle DEC. So let us select these two triangles and then we will continue. So in triangle ABE and triangle DEC, in triangle ABE and triangle DEC, triangle ABE and triangle DEC, angle ABE is equal to angle EDC. Angle ABE is equal to angle EDC. Is equal to angle EDC. So this is according to the data. So here angle ABD is nothing but angle ABE itself. Angle ABD is equal to angle ABE itself, and angle BDC is equal to angle EDC, right? That I have written there. So one pair of corresponding angles have become equal. So but if you want to prove these two triangles to be similar, then we need another pair of corresponding angles. So now this is a straight line and this is a straight line. So therefore these two angles should be equal. So on what basis? They are equal on the basis such that they are vertically opposite angles. So that is angle AEB is equal to angle DEC. Angle AEB is equal to angle DEC. So that is vertically opposite angles. So therefore in both the triangles, two pairs of corresponding angles have become equal. So therefore both the triangles are equiangular. So therefore triangle ABE and triangle DEC are equiangular. So if two triangles are equiangular according to A criterion, so they should be similar to each other. So therefore triangle ABE is similar to triangle DEC. So reason is AA criterion. So according to AA criterion, both the triangles have become similar. Now, if you want to prove that BD is equal to 5BE, then we have to take the ratios of corresponding sides. So let us take all the three ratios, then we will ignore one and we will take the remaining two, right? So for that we have to write the third angle here. So this becomes the third angle, because this angle and this angle are equal, this and this are equal, so therefore this and this angle should be equal to each other. Right, now let us write the corresponding sides. So let us start with triangle ABE. Now, for this, in triangle ABE, this is the single mark. Opposite to single mark is AE, and in this triangle, opposite to single mark is EC. So therefore, AE by EC. AE and EC are the corresponding sides. So therefore, AE by EC is equal to, let us go with the second pair, double mark. In triangle AEB, side opposite to double mark is AB. In this triangle, this and these are corresponding angles. So therefore, side opposite to double mark is DC. So AB by DC. AB by DC is equal to, let us write the third pair. This is the third pair of, this is the third angle. So triple mark opposite side in triangle AEB is BE. This is the triple mark here because they are corresponding angles, and opposite with this is DE. So BE by DE. BE by DE. So reason is corresponding sides are proportional. Corresponding sides are proportional. Now, we have to prove that CD is equal to, we have that CD is equal to 4AB. So take a ratio which is having CD. Okay, CD is here, and AB is here. Okay, BD. Okay, we don't have BE. So BE is here. So ignore these two and take these two ratios. That is how we have to take. So therefore, AB by DC is equal to BE by DE. Right. So now, what is CD equal to? It is 4AB. So instead of CD, that is DC, CD are one and the same. So CD is equal to 4AB. So therefore, AB by, instead of CD, I can write 4AB. So 4AB is equal to BE by DE. So here, AB and AB gets cancelled. So remaining thing is 4. Here one remains. So BE into 4 is 4BE and DE into 1 is DE. So DE is equal to 4. 4 into BE is 4BE. DE is equal to 4BE. This is the result what we have got. That's the result, very simple result. Now, what is this BD equal to? This entire BD length, the length of BD is the sum of the length of BE plus ED. That is BE plus ED is BD. So we can write that. So BD is equal to BE plus ED. BE plus ED. Now, BD is equal to, what is, okay, we'll write this BD here itself, plus, what is DE or ED equal to? DE or ED is equal to 4BE. So we'll write 4BE, instead of ED, you can write 4BE. So BD is equal to, what is 1BE plus 4BE? It is 5BE. So this is the result what we have required. So hence it is proved, right? So this was a problem asked in one of the final examinations of Cbse and also in the state syllabus examinations, SSLC examinations. So I hope you enjoyed the entire session. These are all very important problems. You have to practice this. Since you are seeing what I am doing on the board, it looks very easy. But when you start applying your mind, your thoughts, your understanding, your skills into the problem, then you will face the real situation. So therefore, please practice the problems, right? So in tomorrow's session also, we will be going with some more problems on riders on AA similarity criterion. So practice this well so that the next coming problems will be a little bit still harder than this. These are all the conceptual riders what I am doing. So in tomorrow's session, we will be going with still more good problems on AA similarity criterion. So until that, stay home, stay safe and keep learning. Thank you.